In video 3.6.8, Max and Min learned that when two lines meet, the angle between them measures how far apart they are, like the angle between the two hands of an analog clock. They also learned that the four angles inside a rectangle or square are called right angles, which are shown by drawing a little box for each one. Recently, for homework, the twins were asked by their teacher, Miss Maxwell, to think about how different angles could be compared. For example, how do we know if an angle is less than, equal to, about the same as, or greater than a right angle? Sometimes two angles can look about the same even though one is bigger. How can we know which one? Max and Min brainstormed these questions with their friends on the school bus after school. Brainstorming sessions nearly always brought up good ideas. This time, someone pulled out their geometry set from their school bag and showed the others how their compass, which is usually used to draw circles, could be adjusted in or out to match and therefore compare different sized angles. This worked pretty well for the smaller angles, which were less than a right angle, but the compass was limited in how far apart its arms could move, so it could not make the biggest angles. Max suddenly remembered seeing his pop just the week before in his workshop using a carpenter's folding ruler, and it gave Max a great idea. Pop's ruler folded about a pinned joint, which allowed the two arms to turn all the way around each other. Max imagined using a paper fastener to pin two rectangular lengths of cardboard together. The cardboard arms would then be able to be turned all the way around each other, just like the arms of an analog clock, so they could be used to make any sized angle. Min and their friends thought Max was a genius for coming up with that great idea. Back home, the twins took only a few minutes to make Max's angle tester. "Did you know," said Min, "that different sized angles have names?" "You mean like Mary and Matthew?" replied her brother with a grin. "Very funny, Max. Let me show you what I mean." And Min took the angle tester and started to make some different sized angles with it. "Okay," she continued, "we already know that an L-shaped angle is called a right angle. If we make the angle smaller than a right angle, like this, we have an acute angle." "Because small angles are cute," interrupted Max. "Ha ha, you are funny today, brother," replied Min. "I said acute. All angles smaller than a right angle are acute angles. If we add two right angles together, like this, we form a straight line. So this is called a straight angle." "What about angles between a right angle and a straight angle, like this?" asked Max. "Well, any angle bigger than a right angle and smaller than a straight angle is called an obtuse angle," answered Min. "And Max, we made this angle tester to turn all the way around. When it does make a full turn or a full circle, the angle made is called a revolution." We can also think of a revolution as adding four right angles together. Finally, there is also a name for angles that are larger than a straight angle and less than a revolution, such as this angle. These angles are called reflex angles. Just then, Max pointed to the analog wall clock. Look, Min, it's 6 o'clock and the arms of the clock are forming a straight angle. Yes, Max. And if it was 3 o'clock, with the hour hand pointing at the 3, the arms would be forming a right angle. In fact, we could look at this clock for 1 hour and watch just the minute hand rotate through all the different angle sizes from 0 at 12 right through 1 revolution back at 12. Or if you want to spend 12 hours watching the clock, you can see the hour hand do the same, added Max. Since that day, Max and Min have often noticed the different sized angles that are formed by all kinds of everyday objects, such as the angles in the balustrading of the school stairs, or the angles on their soccer ball, or even the angles made by buildings when you look up at them. And they can name them all: acute, right, obtuse, straight, reflex, and revolution. Notice the angles formed by the objects around you and practice naming them. Now you can watch this video again or try the quiz and look at the chart that comes with this video.